Okay, so we have a question right here. It basically says that scientists use weather balloons to carry equipment into the upper atmosphere to monitor weather conditions. The photograph shows a weather balloon. Upthrust acts on the balloon. The balloon is released and accelerates upwards. State what is meant by upthrust. Okay, so basically let's understand what is happening here. This is our weather balloon and it has been affected by, you know, number one, the equipment's weight, which is acting downwards, and then it has an upthrust. And what is actually upthrust? Upthrust is basically an upward force caused by, any fluids. Fluid means like by air or water, right? And it always acts opposite to the weight, right? So basically we just have to mention that. So it is upthrust is the upward force exerted by a fluid on an object, on an opposing its weight. Okay, so part B says that when the balloon is released, the initial upward acceleration is 4.8 meter per second square. Initial upward acceleration show that the weight of the balloon and the equipment is about 13 newtons. Volume of the balloon and the equipment is given, and density of air at ground level is given as well. So first of all, we will use the formula of force, which is the sum of forces is equals to ma. Okay, so what is the sum of forces? The sum of forces is basically the upthrust, which is acting upwards, and the weight, which is acting downwards, right? Also, your motion of direction is positive upwards because the balloon and the equipment is accelerating upwards, is going up, right? So that's why our motion of direction is positive upwards, right? So your sum of forces will be upthrust minus weight, right? Because upthrust, it has a positive value as it is with our motion of direction, and weight is opposite of our motion of direction, right? So it has a negative value, and this is ma. How we will find upthrust? We can use the formula of upthrust is equals to mg, similar as weight is equals to mg, right? Now, in order to find the upthrust value, means the mass of this upthrust, right, we can use this as we have discussed in the previous part. What is upthrust, right? Upthrust is caused by fluids, means an upward force is caused by fluids, right? Basically air and stuff. So this is talking about air and volume, right? So it's basically linked to the upthrust part, right? So how we will find the mass from the given data of volume and density, right? So we can use the density formula, which is density is equals to mass over volume. So we need the mass part, so it will become mass is equals to density times volume, right? We can input this in here and you will get U is equals to density, which is 1.23 times volume, which is 1.63 times gravity, which is 9.81, and it will give you the value, which is 19.668 blah blah blah. If you round it off, it will be 19.67 newtons, right? I would recommend you use this value for further calculations, right, so that you don't have any inaccuracy in your values, right? So now we have upthrust, we can input it here and then we can find the mass from this, right? And as you know, and the mass from here, because weight is equals to mass times gravity, right? So we don't know mass for both of that stuff, right? So we can use the upthrust value and the acceleration to find the mass, right? So it will be 19.668 blah 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 minus weight, which is mg, right? You have g as 9.81, and you need to find mass again. Your acceleration is 4.8, right? So now it will become 19.668 blah blah blah, and it will be m times 9.81, right, times 9.81 plus m times 4.81, right? Now you can basically take m, outside the brackets, so you can write it like this. Basically you can take it out as a common, so it m, and it becomes 9.81 plus 4.81, right? So you can basically, it's like this, 9.81 m plus 4.8 m, right? So you can take m as common and it will result you in this thing. Okay, so now if you divide this thing from 19.68, your mass value will be, right, if you divide 9.81 plus 4.8 and divide it with 19.68, it will give you 1.346205 blah blah blah. If you round it off, it will be 1.35 kg. Yeah, 135 kg. You can write it like this. I would say use this value for further calculations, right? So now you need to find the weight. Weight is equals to mg, which is 1.346205 blah 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 times 9.81, right? And then you should get your value as 13.2062 blah blah blah, and if you round it off, it will be 13.20 newtons, right? So hence we have proof that our weight of balloon and equipment is about 13 newtons, right? Okay, so part 2 of the same question says that the graph shows how the density of air decreases with height above the ground. The scientist wants to make measurement at a height of 25 kilometer where the balloon would stop rising. The balloon will expand as it rises and will burst if the volume exceeds 50 meter cube. Deduce whether the weather balloon could support the equipment at a height of 25 kilometer without bursting. Okay, so what is actually happening here? This is your balloon, okay, and it is equipped with the equipment. Now the scientist wants to make the measurements, right, where the balloon would stop rising. So this suggests that at a height of 25 kilometers, basically it would stop rising, right? So when it stopped rising, it basically means that your weight and your upthrust are now equal, right? So your weight value was 13.2 newton from the previous part, so your upthrust is now 13.2 newton as well, which is causing the ball to be stationary and not move. Okay, so now we need to figure out whether the volume exceeds the 50 meter cube at the height of 25 kilometers, right? If it bursts, the of course the equipment will fall down and it will not help the scientists at all. So in order to find the basically the volume, we can use the formula of upthrust, right? Upthrust is equals to mg, similar as weight is equals to mg. Okay, same thing as from the previous part. So we actually have the upthrust, right, because the balloon is stationary, so we can use the value of the weight, which is 13.2 newtons, and you don't have mass, so you can use the density formula, which is density is equals to mass by volume, right? So if you rearrange it, it will be mass equals to density times volume, right? So now basically if you substitute it here, it will be d times v times g. Okay, now we basically need the density part, which we can get from the graph. We need to figure out volume. We have gravity value, which is 9.81. so this is your 25 kilometers, right? 25 kilometers, and this, well, let me zoom in. So this will be right here. Okay, which is 0.04, and it's a little bit above, so let's say it's 2. You can guess it out yourself as well. Basically the mark scheme gives a range, and if you get it within the range you will have a correct answer, right? So I'm gonna write 0.042. Yep, so it's 13.2 is equals to 0.042 times, we need to find the volume, and we have gravity, which is 9.81, right? So if we divide it, right, which is 13.2 by 0.042 times 9.81, right? We divide these two value with this, right, basically. So your value comes as 32.03727, sorry, wait, 0.03727, which if you round it off, it is 32.0 meter cube, right? So basically it is not exceeding, so we will say 32.0 is less than 50 meter cube. So yes, it will support the equipment without rusting. Okay, so part C says that a weather balloon made up of a strong material will rise and eventually stop expanding. It will continue to rise until it reaches a maximum height. Okay, explain how and why the velocity of weather balloon changes from release until it reaches its maximum height. Ignore the effect of viscous drag force. Okay, so basically what is happening here? So this is your balloon, and your material is attached with your balloon, and when it releases, your upthrust, is greater than your weight of the balloon with the equipment. So it causes a resultant upwards force, right? So you have a resultant upward force, which means that you have an increase in acceleration, which equals to increase in velocity of the balloon, right? So as the balloon is rising, right, the air density is basically decreasing, right? So now let me explain you how this actually is affecting the upthrust as well, because the upthrust is getting reduced due to it. Okay, so we can use the upthrust formula, which is upthrust equals to mg, and in order to find mass we will use the density formula, which is density is equals to mass by volume, right? So if you rearrange it, it is mass is equals to density times volume. Okay, so if you substitute it now, it will be upthrust is equals to density times volume times gravity. Okay, so now if your density is decreasing, your upthrust is decreasing as well. Okay, so now as time goes by, it will eventually reach to a maximum volume, right? And still there will be, the balloon will still go a little bit more up before it becomes equals, right? Even though the maximum volume has reached, right? And if maximum volume is reached, the balloon will burst, right? But because of the balloon, as it is made of a strong material, it will not burst immediately, right? So it can go a little bit more up before it reaches to a point where it will actually just explode, right, or burst. So now there will be some point where the upthrust and weight will become equal, means there will be no resultant force, right? No resultant force. Okay, so which means the balloon will stop accelerating. But remember that the balloon will not immediately go to, will not immediately stop. It will still go a little bit more up because of inertia, because it has velocity as it was coming from below, right? So it will have a little bit of velocity, so it will go a little bit more up, right? Which will cause it to have which will cause the air density to be more or less, which will cause more upthrust, less upthrust. Now here your upthrust is basically less than your weight, right? Which will cause a small, basically in a small amount, resultant force to be downwards, which means you have a deceleration, acceleration in negative part, right? Because you were having a motion of direction positive upwards, right? So basically, in a very simple way, your balloon goes up, right? It reaches to a maximum volume, but it still goes a little bit more up before before it reaches to upthrust is equals to weight, where it will no longer go up, but because of the previous velocity, it will still go a bit up before the velocity turns to zero. And now because the balloon has gone a little bit more up, your upthrust value has become more or less than weight, so it will go down a bit, right? It will have a resultant force down, the which it will cause deceleration, right? So now it will go a bit down, and then it will finally reach to a point where it reaches the maximum height, right? So basically you just have to explain these simple steps, right? I hope it clears out everything, right? So now let me write it in the word form, right? Okay, so I have written the answer right here. So the answer is, when the balloon is released, the upthrust is greater than the weight, creating a resultant upward force. Due to this upward force, the ball accelerates upwards, meaning its velocity increases. Okay. As the balloon rises, the surrounding air becomes less dense, reducing the upthrust. Okay. When the balloon reaches its maximum volume, the upthrust continues to decrease as it gains altitude, means the height. At some point, the upthrust becomes equals to weight, meaning there is no resultant force and the balloon stops accelerating. As the upthrust becomes less than weight, why this happens, why it's becoming less? Because I have told you that because they had a previous velocity, the balloon went up a little bit more, even though it reached to the point where upthrust was equal to weight, right? So here it says, the as the upthrust becomes less than the weight, a small resultant force is created, causing the balloon to decelerate, means going down. Eventually the balloon's velocity decreases to zero and it comes to a rest at its maximum height, right? So basically this is your final answer.